Greetings, M Squared here. Today we're going to talk about compound inequalities. So compound inequality is an inequality that's made up of two or more inequalities. We're going to stick to two. And we're going to solve them and graph them. But first we're just going to talk about graphing them. So there's two types of inequalities. That 90% of the time it'll be these two types. So when you do compound inequalities. So this is our solution. This is our graph. Now you'll see the word or and the word and. So there's two kinds of compound inequalities that we're going to talk about. Ors and ands. Ors say, hey, it's either less than a certain number or it's greater than a certain number. Every once in a while you might see the same sign, but this is usually what it'll be like. It'll be two circles, opened or closed, depending on if there's a line under them, and they'll be going opposite directions. So 90% of the time when you have an or, this will be the case. When you don't have that, it's when they're facing the same direction. And we'll do an example of that. So this is an and. There's two ways to write a conjunction or an and inequality. And you'll see that one is with the word and, kind of like over there where we did the word or. But also to write it compound like this, where the x is in the middle and it's between two things. So an and is between two numbers. So this one's between negative 2 and 3. So this says between negative 2 and 3. X is greater than, if I read it this way, greater than negative 2 and less than 3. So for an and inequality, both things have to be true at the same time, and you're graphing where they are both true at the same time. Because I could graph f as x is greater than 2. That's from here all the way there forever. And x is less than 3. That's from here all the way there forever. But where does it happen? At the same time, just in here. So that's the difference. And this one is all of those and all of those. They don't have to be the same. It's either or. So we're going to graph a few of these. So I have a number line, and I'm going to I have a couple examples here, a few examples, and we're going to graph them. So this says x is less than negative 3. So I want to keep in mind that it's going to be an open circle and a closed circle. I always like to think about that before I go to graph it. So I'm going to put an open circle at negative 3, and I'm going to go to the left because it says it's less than. Or x is greater than or equal to, so closed circle at 4, and to the right. So that is how I would graph that one. Okay, let's try another one. This is an and, so I expect it to be an in-between thing. So I go to negative 1, and I know it's a closed circle because that line right there, this is going to be a closed circle as well. And it has to be greater than negative 1 or less and less than 3. So at the same time, that would be everything between them. Okay, less than 1, so it's an open circle, or less than 5. So let's talk about that for a minute. It's less than 1, which would look like this, right? Or less than 5, which would look like this. And since it's an or, it doesn't matter if they're both the same or not. It just is one or the other. And since all of the ones that are less than 1 are included in the less than 5, because negative 2 is also less than 5, then I would just have one arrow. So sometimes a compound inequality doesn't look like a compound inequality when it's graphed because one is overlapping the other, and we only have to graph the one that includes the most of them. So that's one of those strange, weird cases that doesn't happen a lot, but you want to be aware that it could happen. Okay, so x is greater than negative 4, so that's all of those, open circle, and x is greater than 0. Okay, so on this case, it has to, because of the word and, we can't just start here because it has to be the ones where it's both the same. So I actually wouldn't even graph that part, because negative 2 isn't also greater than 0. So I can only graph the ones where they are the same. So over here, it's both, like the number 3, it's both greater than negative 4 and greater than or equal to 0. And greater than or equal to would mean I have to do a closed circle there, because the 0 is included. All right, so that's another kind of weird case where it's a conjunction, but it doesn't look like it's in between two things. But most of the time that won't happen, but you got to be prepared. So x is less than 2, so it's going to be that way, and x is greater than 4. So x is less than 2. I'm just going to do it down here because I want to show you what happens. So this one goes to the left forever, this one goes to the right forever. They never intersect. So there's no solution here. So you actually wouldn't graph anything. This this would be your graph, not these guys. That was my example. But it would just be an empty graph showing that there's no numbers that work. And then this final one, x is less than -3. So we would go like that, open circle, or x is greater than -5, or equal to -5. And so you'll see that this one's going to go that way forever, that one's going to go that way forever, and they overlap. And when that happens, what means is that any number you pick would work. It doesn't matter what the number is. It's always going to either be less than this or greater than this. So those are some weird cases for you to think about. Okay, now let's get on to actually solving and graphing. We're going to do 4 problems. So on this particular one, we have an OR. So you want to be thinking it's probably going to be, 2 circles pointing out. Most of the time it will be. So we've got to do them separately. So sometimes I draw a line down and I just work with this one and then I work with this one. So I'm going to subtract 4 from both sides, so I get -x is less than or equal to -7. But I'm not done until I get rid of that -x, so I would divide by -1. And remember what happens when we divide by a negative. We're going to have to switch our inequality sign. Okay, so I put the word OR there. The word OR is very important because it's this or whatever I get over on the other side. So I'm going to add 5 to both sides. So I get 2x is less than 12. I'm going to divide both sides by 2. So x is less than 6. So over here, x is less than 6. So they're asking you to solve and graph. This is the solution. It's really important that you know that that's the solution, because sometimes they don't ask you to graph, and that's the answer. And if they ask you to solve and graph, you need that solution as well as the graph. So I'm just going to put a 6 here and a 7 here, and the 6 has an open circle, the 7 has a closed circle. The 7 is x is greater than, so that's all those points over there. Those are the ones bigger than 7, and the ones less than 6 are over there. So that's what my graph would look like. All right, I'm going to try another OR. So I'll draw my line just because I like to. So I'm going to add 7 to both sides. And 13 plus 7 is 20. So now I have 5x is less than 20. I'm going to divide by 5. And so x is less than 4. Or, now I've got to see what shows up on my other side. I'm going to subtract 3 from both sides. -4x is greater than 14. And I'm going to divide by a negative. Notice I'm dividing by a negative. I always have to remember what's happening when I'm dividing by a negative. So I'm going to get x, because those are going to cancel out. That's a 1, -4 divided by 4. My greater than sign is going to have to go to a less than sign, and I'm going to get a -7/2, which is equal to 3.5, -3.5. So when I'm graphing, put some more numbers on here this time. So let's say that's 1, 2, 3, 4, 5, 6. So at 4, I have a open circle, and at 3, oh, I forgot. We have to go to -3.5. I did not make my graph big enough. Okay. I was thinking 3.5. We're going to erase those numbers right there. We're going to say that this is still 4, but we're going to go to, let's see, we're going to count by 4s. 0. Sometimes you can do this. You might not like it. But there's a -4. I'm going to put 1, 2, 3, 4. Not quite what I wanted it to be, but we'll improvise here. So -3.5. This is -3. So -3.5 would be right there. Just do that in a different color. Okay, so x is greater than 4 or less than -3.5. All right, we're going into the ands now. Notice that this one's written with the word and done separately, kind of like the ORs. This one's written as just kind of one compound inequality. So in these cases, your goal is not to get x on one side, but to get x in the middle. And since there's 3 parts, whatever you do to the middle, you have to do the left and the right. So we're going to subtract 9 from the middle, because our goal is to get x alone in the middle, but we also have to do that from the left and the right. So that would be -21 is less than or equal to 7x, which, because that's a 0, which is less than 7. And then we're going to divide everything, all 3 parts, by 7, because we want to get x alone in the middle. So we're going to get -3 is less than or equal to x is less than 1. And when we graph that, it's going to be kind of one of those combined ones. So we're going to get 1, 0, 1, 2, 3. Whoops, -1, -2. So we have a closed circle at -3. We have an open circle at 1. And what we're graphing is what makes it true for both of them, or everything between those two. And our final one for today, we are going to make sure that we do them separately. We don't want to do something over here and over there. We're going to do them separately. We're going to add 5 to both sides. We're going to get 2. We're going to get x alone on one side. So first we add to get rid of the -5 or the -5, and then we're going to divide by 2. So x is greater than 4. And, so we're going to put that word down if we're doing them separately. We're going to subtract 7 from both sides. So -4 is less than -32. Oops, I forgot my x. There was an x there. Then I'm going to divide by -4. Notice I'm dividing by a negative. You've got to kind of get used to that. And if you do it if you forget it, then go back before you turn in your assignment or your quiz or test and make sure you go and check them all. So that's 8. 32 divided by 4. The negative divided by negative is always a positive. So my graph. So it has to be bigger than 4, and it has to be bigger than 8. So if it's bigger than 4 and bigger than 8, then all the ones that are bigger than 8 is really all I need to do. So we've got, let's see, 0, 2, 4, 6, 8. So open circle at 8, and we're just going to make our arrow go that way. And it's just all the answers that are bigger than 8, because that would satisfy both conditions. So one thing you can do is you can pick a number bigger than 8. Like, let's just pick 10. 10's an easy number to work with. And let's put it into this one and this one, and it should work in both of them. So if we put a 10 in for x, we get 2 times 10, which is 20. 20 minus 5, which is 15. And we ask ourselves, is 15 bigger than 3? Yeah, it works for that one. Okay, we put a 10 in here. -40 plus 7 is -33. Is -33 less than -25? Yeah, it is. So sometimes it helps. If you plug this exact answer in that you got for this, it should make them equal. But that's one way to check too. Your solution is just to pick something in your range that you think it is and check it out in both of the equations. Okay, so that's, I should say, inequalities, not equations. So that is solving compound inequalities. Good luck with that. M squared signing out.